Hi, welcome to another Polkadot tutorial. In today's video, we're going to see how we can verify an extrinsic that we're signing. We will do that with the Polkadot.js user interface, the browser extension, and the ledger device. An extrinsic in Polkadot and all substrate-based blockchains is a type of transaction. Substrate is based on a modular design where we have different modules that contain different functions with the same logic. For example, in here we are on the Polkadot.js user interface on the Kusama network. We can go on the developer tab, Extrinsic, and in this section here we can do custom transaction. In order to do that, we have to first generate an extrinsic. So we have to generate a type of transaction. We first select the type of palette or module that we want to use. For example, the balances palette that is dealing basically with transfer of tokens between accounts. And then within the palette, we select the function. For example, in this tutorial, we will use the transfer KeepAlive. This function will check that at the end of the transaction, we will have enough funds to keep our account on the blockchain. It is important to remember that if the balance of one account on Polkadot goes below the minimum deposit, that is 1 dot, the account will be ripped and the remaining funds will be burned. This is to avoid the existence of dust account that they just take space on the blockchain. But why we should check and verify always the extrinsic that we are signing? This is a very important step and a security measure for everyone that is transacting. There are different types of attacks that might take place when you're transacting using a blockchain. A clipboard attack, for example, is an attack on the clipboard memory. This is a part of your computer that is dedicated for copy and paste operation. For example, an attacker might install on your computer a malicious program that is able to detect when you're copying cryptocurrency addresses. The program works in a way that when you are copying and trying to paste an address, he will basically paste a different address, the one of the attacker. So you're thinking that you're sending the funds to the receiver that you know, but in reality, you are sending the funds to the attacker address. Before diving into today's tutorial, if you find these videos helpful, please hit the like and subscribe buttons below, as this will help other people to find our content. And if there is something that we didn't cover yet and that you're interested in, drop us a message. Here we are on the Polkadot.js user interface and we are connected to an RPC node on the Kusama network. We will now try to do a balances transfer KeepAlive extrinsic between the stash account and the controller. In order to do that, we go under the send button in the stash account, we click it, and here we can check the sender, the receiver, we can specify the amount of tokens that we would like to send. And then this is a transfer KeepAlive check, and we'll make sure that in our account we will still have this existential deposit so that we can keep it on the blockchain. We can then click on make transfer. And here on the top left corner, we can see the type of extrinsic that we're signing. This is a balances transfer KeepAlive. We can expand and see some more detail. For example, the receiver address and the amount of tokens in Planck's unit. The fees that we will pay in micro KSM for this transaction. And remember that these fees are actually deducted from the balance after the transfer, which means that you always have to make sure that you have enough balance on your account to pay for the fee, and also so that you can still have the existential deposit and keep the account on the blockchain. And here we also have the sender account. If you are happy with all this information and everything looks all right, we can go ahead and sign and submit. The browser extension that is talking to the UI will display once again all the information of this transaction. We can see the name of the account that you're using, the address, the requester who is requesting this signature. Then we can see that we are on the Kusama chain, the version of the runtime at the time of signing this transaction. The nonce, this is a unique number that is specific to your account, and it will increase with the number of transactions that you will do with this account. The method, this is the extrinsic, balances transfer KeepAlive. We can expand it and see once again the receiver address and the number of tokens that we are sending in Planck units. And also we have some information about the type of extrinsic that we are using, same as the transfer extrinsic, but with the check that the transfer will not kill the origin account. So this function, once again, will check that we have enough fund to have that we have the existential deposit at the end of the transaction after paying the fees, so that we can keep our account on the blockchain. And then the lifetime, this is a mortal transaction that is valid between these blocks, which means that this transaction cannot be executed twice. If this information looks alright and we are happy with it, and especially is the same information that we just checked on the UI, we can go ahead and sign for this transaction. Alright, we just send the KSM from the stash account to the controller. Now we will try to do the same thing, but we will try to use a ledger account and to transfer some funds to the controller. Before click on send, make sure that you plug your Nano device to your computer, that you unlock it with a PIN code, and that you are on the main menu. Then the UI will display the same information what we saw before. We have our account here, the ledger, and then we want to send it to the controller. We specify the amount of KSM tokens, and we can make the transfer. We can review here the extrinsic, where we have the receiver here, the amount of KSM tokens in Plancks, the fee, and also the sender. If you are happy with it, we can go ahead and click sign and submit. The browser extension will show us some details about this transaction that we are doing. We can also double check again that everything looks alright, that we have here this receiver address, and this is actually the same as the address that we have here. And don't worry if there is a ledger error in here that you have to refresh. Before clicking on refresh, go on your ledger device, enter your Kusama app, and when you see the Kusama ready screen, you can click on refresh, and then you can also click again on sign on ledger, go back to your ledger device and start to review the transaction. You can click to the right and see that this is a balances transfer KeepAlive transaction, that the destination is the controller, that the amount of KSM is 0.0001, and then we can choose to approve or to reject this transaction. In this case, the information displayed on the ledger is the same as the information that we saw on the browser extension, and is also the same as the information that we saw on the UI in the first place. So we are sure that we are sending our tokens to the right address and that we are signing the extrinsic that we want to do, so this balances transfer KeepAlive, and we can proceed and approve this transaction. Alright, we can see that we sent 0.0001 tokens, KSM tokens, from the ledger device to the controller. A rule of thumb when you're using the ledger is that whatever displays on the screen of the ledger is the truth. So there are two possible scenarios where there might be some attack that is not necessarily a clipboard attack. The first scenario is that you want to sign for an extrinsic A, and the browser extension is corrupted, is malicious, and is gonna do A, but then it will actually send to the ledger B. So what is displayed on the ledger is different of what is displayed on the extension. Do not sign this transaction, reject it on the ledger. Another scenario is that you're using a third-party app that is malicious and is talking to a browser extension that is genuine. In this scenario, on the third-party app, you want to do A, but the extension will show B and also the ledger. So the ledger and the extension will show the same thing, but actually that thing is different from what you want to do. In this case, also do not sign the transaction. Remember always to verify the extrinsic that you're signing. It takes a little bit of time before sending a transaction, but it's definitely worth your extra time. The browser extension will always warn you if you are on a blacklisted website, but it might not be always the case. So you always need to expand the detail when you're signing the transaction on the UI, on the browser extension, and especially on the ledger if you're using a ledger device. I hope you learned something today about verifying extrinsic and being extra vigilant when you're sending a transaction. And I see you in another video.